All right, guys. I can hear all of your voices on the tape now. Please. Thank you. Our goal today is that you can understand the 68, 95, 99.7 rule and how to apply it to problems when you're thinking, I've never heard of something like this. What is this for? Well, the first thing you need to know is this only applies to the normal distribution. What is the normal distribution in problems that will be stated? The grades on, or the scores on the ACT exam are normally distributed. The heights of women are normally distributed. In all statistics problems, I shouldn't say all, in most statistics problems, it will state if something's normally distributed. Now when you get to AP stats, it won't state that necessarily, and you'll have to check these conditions to see if it's normally distributed. But for now, today, we're gonna assume everything we work with is normally distributed. And when something's normally distributed, that means we have the normal curve. And what the normal curve looks like is this. It is a bell-shaped curve. It has a single peak, and it is symmetric. Please draw this picture with the -3, -2, -1, 0, 1, 2, and 3. And I'll explain why we have that in a second. Yes, question.
When you say distributed normally, does that mean distributed even, or?
Yes, that's a great question. So Sierra's asking, like, what exactly does that mean it's distributed normally? So the ACT is distributed normally. If I would plot, and you don't copy this right now because I'm gonna erase it here in a second, but if I would plot the scores of people who took the ACT as a histogram or a dot plot, this is what the distribution would look like. So it's symmetric. So we're gonna have the average in the center, and then it will kind of, the people up here, the top scores, not as many people get that, right? The bottom scores, not as many people get that. So that's what I mean, when it's distributed normally, it has the normal distribution, which means it has a normal curve. And if I would plot all the scores, that's what it would look like. Okay, does that make sense to you? Okay, so I'm gonna erase that right now. And what I think is really cool about the 68, 95, 99.7 rule is it's a way to measure location of a normal distribution. And we can draw some conclusions about that normal distribution. And that's what statistics is. It's telling the story behind these numbers, what is going on. So the story about the 68, 95, 99.7 rule is, in the center is our mean. And we put 0 there because if you get an average of 21 on the ACT, and the ACT's average is 21, and you find the Z-score, you don't need to write this down, 21 minus 21 over the standard deviation means your Z-score is what? 0. Why? Because you got the average. Your Z-score is the exact standard deviation above or below the mean. So that's why we have the 0 right there. So what does this 1 represent?
People are 6.1 or above that.
They're above average. They're one exact standard deviation above average. So I'm going to put 1 SX for standard deviation. These people are
2 SX.
2 SX, 2 standard deviations above the average.
They're clocked dots.
And then 3 standard deviations above the average. And then we go backwards. This person who had an ACT here at -1, that means they're 1 standard deviation where? Below average, yeah. 2 standard deviations below average, and 3 standard deviations below average. In a normal distribution, we always mark 3 standard deviations above the mean and 3 standard deviations below the mean. Can you get a Z-score above 3 or below -3? Yes, you can. Well, let's talk a little bit more about it. If I would take 100 people who took the ACT, randomly get these people, 68% of them would have an ECT score between 1 below the average and 1 above the average. So 68 of the 100 people I would ask their ECT score would be somewhere between this -1 and this 1. You do need to write this down, yeah, please. Yes, questions?
And is that for all things?
For all normal distributions, if I would plot the heights of women, 68% of women are between -1 standard deviations below the mean and 1 standard deviation above the mean. The heights of men, so on and so forth. Do you know how they say your average temperature is 98.6, right? 98.6, right?
Yep.
Okay, well, there's a standard deviation involved with that. So if you go to the doctor and they say, oh, you're at 98.2 or 98.8, they're not concerned. Because you're within usually that 68% mark, or even that 95% mark, okay? Which leads us to the next one. If you have a question, raise your hand. Otherwise, please don't talk because we are taping, and my awesome blue snowball can capture anyone's voice from the room. Okay.
So when I said hi right now, I can hear myself when I go like.
You can. Okay, ladies and gentlemen, 95% of the population will fall within 2 standard deviations of the mean. And finally, 99.7% of the population will fall within 3 standard deviations of the mean. Which this is a rule that will always, it's true for everything that is normally distributed. Can you have a standard deviation 3 above the mean in a normal distribution? Yes, my son's head size is right there. 99.7% are within there. So it's pretty rare to have a head size up here, right? Those of you who are at Relay for Life, you saw him, it doesn't look that funny, I promise. Okay? All right, listen up. Thank you. We can draw even more conclusions about these standard deviations. In fact, we can say between 0 and 1, this area, 13, I lied, guys, I went to the wrong one. 34% of our population is between 0 and 1 standard deviation above the mean. And 34% of our population is between 0 and -1 standard deviations. .5% of our population is between a 1 and 2 standard deviation above the mean. And the same goes for right here. .5%. Between 2 and 3 is 2.35%. And right here, 2.35%. And then finally, if you are my son, you're right here. The chances of that is going to be 0.15%. And over here, so we don't have a lot of time right now. We can get through this problem. It's only one problem, so let me quickly go through it. I'm not going to ask for any questions or volunteers. We're going to quickly just apply this now to a problem so you can see what this means. We're going to talk about the ACT since you guys are going to be taking the ACT here in a couple years. Please write down the average ACT score is 21 with a standard deviation of 5. The first thing that you will have to do is there's going to be a number line. You don't have to draw the curve. You don't need to write this in. Just follow what I'm doing. So draw the number line. I'm going to go a little quick so you can watch the video if you need to kind of rewind. But we got a little behind talking about the tests. Always mark the center with 0, okay? But instead of 0, I lied. I'm going to actually put what? What is the average? 21. And then 1 standard deviation above the mean would be what value? 26. How did I get that? 21 plus 5 is 26. And then 1 standard deviation below the mean would be what? 16. And then I'm going to do it again. 2 standard deviations above the mean would be what? 31. And 2 standard deviations below the mean would be what? 11. 3 standard deviations above the mean, so that's 21 plus 15 for 3 standard deviations. I'm going to be at what? 36. And 3 standard deviations below the mean, I'm going to be at 6. Please mark your mean so you don't forget. The first question is, John, and you don't need to write down the problem, just do it with me right now. John scored a 26. What percent of students scored higher than him? So John scored a 26. John is right here, I'll put it in green. What percent of students scored higher than him? That means he's right here, and the little bit right there. So I'm going to go to my chart right now, and I'm going to see that this is 1 standard deviation above the mean, 2 standard deviations above the mean, and 3 standard deviations above the mean. I'm going to go to the chart, and I'm going to use that, okay? 1 standard deviation above the mean is 13.5%. 2 standard deviations is 2.35%. 3 standard deviations is 0.15%. What is that altogether? 16%. I'm going to go right until the bell rings, guys, so stay with me. Blake scored a 16. What percent of students scored lower than him?
16.
The other way, right? 1, 2, and then this little bit there.
Is it the same percentage?
Same percentage, 16%. Okay? What percent of students scored between a 16 and a 31? 16 and a 31 is right here. So 34, 34, and then 13.5. And we add that together. We ran out of time. Hold on, you guys. Please fill out the first page for me for homework tonight, okay? We'll maybe do the second page in class tomorrow just to make sure we have it before we move on.